Good morning, everybody, or actually good evening, or whatever time of day it is you're watching our show here. We've got a great show coming up first and for us today. And first, want to say hello to Hurricane Hal, who's going to co-host this thing with me. And how's it going, Hal?
Good morning, Bill. Doing great. I'm here in Galveston Island. It feels a little fall-like today, a light north breeze. It almost felt like we're actually in fall, which we officially are.
Yeah, dew points are mixing down in the 50s now in the afternoon. It's only going up to around 90. I've decided to call October summer light.
There you have it. Always great to join you on the show, Bill.
Great. So, Hal, why don't you go ahead and introduce our guest as if there's people actually watching that don't know him?
Well, there you go. I mean, everyone knows him. He's so well known. Dr. Phil Klotzbach, Senior Research Scientist at Colorado State University, leading the seasonal tropical weather forecasting there at CSU, which they've been doing since the 1980s. Always great to hear from Phil and get insights on what's been happening so far this season. And what I love about Phil is he'll get into the mechanics of why what we've seen has happened. And so, Phil, thank you so much for joining us on NTWC Plus.
Hey, thanks so much, Hal and Bill and Alex, for putting this on, and thanks so much for having me. And yeah, it's been a little bit since I last talked to you, and we are still in the throes of the Atlantic hurricane season. But to date, if you're not a hurricane weenie, like I'm sure we all are, you'd probably think it's been a pretty quiet season. In terms of an impacts perspective, it has been very, very benign so far. Of course, the season isn't done. We can talk about a potential area that may develop here in 10, 12 days. It could potentially give us a different view of the season by the end. But, as of now, overall, it's been, I would characterize it as a slightly below average hurricane season. So this is kind of the tail of the tape as of last night. 12 storms, an average season has 12 by now. Major hurricanes were a little bit above. Hurricanes were actually a little bit low. And that's a kind of an unusual season in that normally when you have a high, like a lot of named storms for the number of hurricanes, usually your major hurricanes are also low. But this year, we've had low quantity of hurricanes, but the hurricanes that have formed have been quite intense. We've had three major hurricanes, one Category 4 and two Category 5 hurricanes. To kind of dial through all that noise, we talk a lot about this accumulated cyclone energy metric, which accounts for storm intensity and duration. So we haven't had a ton of duration, but the storms that have lasted long have been quite intense. So overall, we're tracking a little bit below normal for ACE through today. So overall, right now, I would say the season, if you had to pick one kind of phrase to characterize it, I'd say it was slightly below normal, but obviously very much below normal for impacts. This is the track map of the 2025 season as of now. So basically here the greens are tropical depressions, the yellows are tropical storms. That one orange line is a subtropical storm Karen, and then Category 1, 2 hurricanes are in red, and Category 3, 4, 5 major hurricanes are in purple. So you can see we've had three major hurricanes. Again, Umberto and Aaron became Category 5 hurricanes. One thing you will note is that, we've actually had a fair amount of traffic in the Western Atlantic, so west of 60 degrees west. And that's an index that we forecast outside of just ACE for the basin. We forecast ACE in the western half of the basin because that tends to be more closely tied to impacts, since that's where people are, that's where property is, generally west of 60. But this year we've had three potent hurricanes west of 60, as well as Imelda, and really all in all, really not much in the way of damage. We've had a lot of beach erosion on the Outer Banks, but really overall a very benign hurricane season, both for the Atlantic. If you look at the Caribbean, there's not been one track in the Caribbean yet this year. The one storm in the Gulf was buried back in June. So really, a very quiet season in the areas where there have been a lot of people, a lot of property, even though we have seen a fair amount of activity west of 60. Obviously, Imelda gave us all a good scare a couple of weeks ago, but thankfully, Umberto's circulation kind of helped drag Imelda out to sea and cause some impacts in Bermuda, but all in all, again, really a pretty benign season, not just for the United States, but also for the Caribbean nation, Central America, so far. Obviously, the season isn't done yet, and we'll talk a little more about that in a bit. One of the reasons why we've been doing well in terms of impacts is we tend to have a trough of low pressure along the East Coast. The Southeast U.S. has generally had, fairly cool temperatures through most of September, a lot of rain, but just overall, we've had this nice trough of low pressure. And when you have a circulation around that trough or area of low pressure being counterclockwise on its southern periphery, the winds are out of the south and out of the west, so keeping storms away from the U.S. mainland. And, there's been a lot of question, why has this trough been there? Why has it been so dang persistent? And one of the reasons why it seemed like that trough kind of set up was after Hurricane Erin, which was a Category 5 hurricane, after that recurved into the westerlies at higher latitudes, this trough kind of set up, and it really hasn't, we weren't able to kick it for several weeks. It just kind of persisted. Now, normally you get these kind of what we call these blocking patterns. They tend to be more common during the Northern Hemisphere winter than in the summer, but you can get these patterns that will get bogged down. And so we've had this trough. It's been good for us, bad for storms coming towards the United States. Again, helps keep them away. In addition to that, when you have these areas of low pressure along the coast, there tends to be a lot of mid-levels in the atmosphere. Tends to be a lot of vertical wind shear, and too much shear, which is a change in wind speed and direction with height in the atmosphere, tears apart hurricanes as they're trying to develop and intensify. Now, this pattern that we've had the last few weeks, obviously this is on a fairly short time scale, but if we look back to kind of the start of the so-called so that typically started in 1995. Atlantic hurricane seasons got a lot busier. From 1995 to 2003, we had 32 major hurricanes in the Atlantic. On average, about a quarter of all major hurricanes that form make U.S. hurricane landfall. But from 95 to 2003, we had 32 majors. Only 3 made a landfall in the continental U.S., that being Opal in 95, Fran in 96, and then Brett in 99. So we ran a really good streak of luck, and even the 3 that hit, Opal and Fran made landfall, caused a lot of damage, but not massive population centers. Hurricane Brett made landfall in Kennedy County, Texas, which is the lowest populated county along the entire U.S. coastline from Texas to Maine, fewer than 1,000 people. So, we generally got very lucky with that trough of low pressure, helping to kind of keep these storms away. And then that pattern basically shifted in 04 and 05. We had 13 major hurricanes in those 2 years. Of those 13, 7 made U.S. landfall. So some of it is basically just kind of the steering. Some is also where these storms form. Obviously, this year, the major hurricanes have formed a little bit farther to the east, and those storms are just more likely to recurve than, say, if storms form in the Caribbean or in the Gulf. Obviously, one of the big questions that we have is, why has the Caribbean been so quiet? And that's pretty remarkable, given normally if you say the Caribbean is very quiet, it's typically because there's too much vertical wind shear. Again, that change in wind speed and direction with height in the atmosphere is too strong. If you look at the shear from August through October so far, the shear in general in that black rectangle, which we call the Atlantic's main development region, has been below normal. So we've had very low levels of shear. Normally, low levels of shear lead to a busy hurricane season. You also will see, if you look at higher latitudes in the northern Gulf, especially along the east coast of the U.S., very high levels of shear. So while we haven't had storms basically tracking that direction, if some storm were to try to track there, it likely would have gotten sheared apart. Now remember, this is, say, like a 45-day average here, or sorry, 65-day average here. Obviously, there could be time periods during this where either the shear was high or the shear in the tropics or the shear was low in the subtropics. But overall, this is kind of the pattern that's been set up over the past several weeks. One of the things that really did give us pause when we were doing our seasonal forecast, and I'll talk more about the seasonal forecast in a minute, was that while we've had low shear from start of August in the deep tropics, if we go back from the 1st of June to the 15th of July, we generally had very high levels of vertical wind shear in the Caribbean. They were some of the highest on record. And so we emphasized this when we put out our July and our August forecasts, was that there was this uncertainty in the kind of the way the tropical circulation was going to set up, because normally if you have high shear in June and July in the Caribbean, that tends to be associated with higher shear in August, September, and October. One of the reasons why our forecasts on a seasonal level have skill is due to basically persistence. So when shear is low in July, it tends to be low in August, and vice versa. And so this year, we saw the high shear in June and July, and with the climate models, we're forecasting low shear in August, September, and October, and that forecast is actually going to verify quite well as the shear overall over the past several weeks and likely through the end of October, when you average across that main development region, will be relatively low. Not as low as last year, but certainly on the low side. And so I kind of wanted to highlight this, and I'll spend a little bit of time discussing this plot because I know it's a little bit busy, but this is a plot showing vertical wind shear for various hurricane season types along with 2025, and showing how it compares with those season types. So the green line is a below average season. So if you look at the green line, it tends to be at the high end of the various season types, especially once you get into July. And that makes sense since higher shear, fewer storms. The orange line is above average, the gray line is average, and the blue line is hyperactive. So if we look at shear in 2025, through the early part of July, it was tracking even above a below average season. So very, very low activity. If you were just to have a model that said, we're going to use shear to forecast activity. But then you see from July through August to September, the shear really did plummet to very low levels, and it generally has stayed below, somewhere between a hyperactive and an above average season through September. And the reason why we talk a lot about the shear is because it is a big driver of the hurricane season. And if you look at historically, the correlation between shear and ACE, so again, an integrated storm metric, and here the correlations drop below that statistical significance level. Those are pretty strong correlations. So this is a negative correlation because high shear, low ACE. And if you look through the early part of July, the correlation is fairly low. And then it really gets strong, even by like the July 20th or so, 30-day average periods ending July 20th. The correlation is quite strong and remains really elevated through early October. And so I think this kind of highlights, normally the tropics kind of lock into whatever mode they're going to be in for the hurricane season by the middle part of July. So this year was quite unusual in that we had very high shear in June through mid-July, and then the shear basically flipped sign. So one of the reasons, again, why we have that high skill with our August seasonal forecast in general is because of that persistence. So the nice thing with July is normally we don't get a lot of storm activity in July, but it really is telling us kind of what we can expect for the rest of the season. Years like 2025, where the shear basically flipped from very high to very low, are quite unusual. The degree of the flip this year was stronger than any year in the historical record back through at least the late 1970s. 2025 has played out in a really interesting way. In some ways, it's similar to 2024, but in other ways, obviously, it's somewhat different. Both of the seasons, however, did have these peak season lulls. So if you look at the center of the graph around September 10th, that blue line is when that blue line peaks. That's climatology, so that's kind of your normal season. If you look at 2024, as well as 2025, we do see overall that when the season on average peaks, both those seasons got very quiet. Prior to that lull, both seasons had a busy period. In 2024, it was Debbie and Ernesto. 2025 was primarily just the one storm, Hurricane Erin, which is Category 5. Obviously, early in 2024, we had Hurricane Beryl. But then you see after the lull, both seasons really ramped up very quickly. 2024 obviously was much more impactful with Helene and Milton, also a bunch of other storms as well farther east in the basin like Kirk and Leslie, whereas 2025 got out of the lull a little quicker. We had Gabrielle, which was a Category 4, followed closely by Hurricane Umberto, which was a Category 5. Then we had Imelda, and since we've had a few weaker storms. But you can see 2025 rebounded, but not to the level of 2024, and also it came back to more average levels more rapidly, which is one of the reasons why 2025 overall is probably going to be somewhere, hard to say for sure, but probably end up being maybe a little bit below normal season, whereas 2024 ended up hyperactive just because of how busy it got towards the end of that season. One of the things that's been interesting both in 2024 and in 2025 is kind of how these lulls played out. So I should mention, we just had a paper accepted on the drivers of the 2024 Atlantic hurricane season lull and geophysical research letters. Happy to share that with any of you that are interested in that. One of the similarities between those two seasons has been that it's been a little more stable than normal. And so I want to point this out that if you look at the average curve of instability in the Atlantic, you'll see that the black line, which is average, goes up through about the middle part of October. So why don't hurricane seasons in the Atlantic peak during October when the atmosphere is most unstable? The primary reason is because the vertical wind shear, especially in the eastern and central Atlantic, gets much stronger as you go through early to mid-October. So normally, your peaks is around September 10th because that's kind of the perfect kind of intersection of still low shear, enough instability, and still very warm waters. But instability, like last year, has been a problem this year where the storms have been struggling with dry air and just kind of an overall more stable atmosphere. And this is one of the challenges of the past couple of years is that normally we associate dry air with a lot of kind of mid-latitude intrusions and a lot of vertical wind shear. So normally dry air and shear go together. The last couple of years, they haven't gone together as much. We've had low shear, but also a fair amount of dry air. And so that poses problematic and a challenge for our seasonal forecast. And I'll talk a little more about kind of how we're hoping to try to get at some of that here in a couple of minutes. But just kind of highlighting how it has been more stable than normal. So again, the black line is average. The blue line is 2025. During the climatological average peak of the season, the Atlantic also broke out with several tropical upper tropospheric troughs. So basically, these are low pressure systems at middle to high levels of the atmosphere, and they are big drivers of vertical wind shear, because if we think about a low pressure system on the southern flank, it's going to have winds out of the west. And we can see here, this is from the 1st of September to the 15th, very strong upper level troughs increasing the shear quite a bit. And so Bill Gray, my mentor at Colorado State, would say if they're ever saying there's a lot of shear and asking where it's coming from, if you didn't know, you had to look at the weather map, you always would just say a trough aloft, because that's a good driver of vertical wind shear. And so if we look at 2025, during this first 2 weeks of September, we tended to have low pressure at middle to high levels of the atmosphere that caused a lot of shear. Similarly, we saw that same pattern in 2024, but in both of those years, that shear pattern relented, and we ended up with quite a busy second half of September. So if you were following, say, Hurricane Gabrielle early in its lifetime, I certainly wasn't thinking it was even going to go. It was in a ton of shear. It was very distorted, had very few thunderstorms associated with it. It was a pretty weak circulation, but it fought through those upper level lows. It got into a more conducive environment and then intensified rapidly, becoming eventually a Category 4 hurricane. So this black rectangle just kind of denotes the region that was really had a lot of these upper level lows during the early to middle part of September. Another factor that kind of has been strange this year is that we've had so normally when we talk about kind of a tropical circulation, we often will talk about being like a wave number 1 pattern. So air going up in one area, air sinking someplace else. This year has been more of a wave number 2 pattern where we've had air predominantly going up. You can see a lot of green over the Indian Ocean. That typically favors the Atlantic. But you also will see that the sinking motion goes all the way back to Africa, so the brown lines. And if you have sinking motion over Africa, that tends to kind of knock down the amplitude of the African easterly waves. And so, if we look at the last couple of weeks, the African easterly waves have been relatively solid and pretty coherent. Prior to that, though, they were fairly weak. So we had tropical cyclone, what we call tropical cyclone seeds, these strong thunderstorm complexes, but they were fairly weak. And so that wave number 2 pattern, I think, wasn't really doing as much in the way of favors in terms of trying to get a busy Atlantic hurricane season. Normally, more tropical circulations in the summer, you will tend to see more what we call a wave number 1 pattern. So air, say, maybe going up from Africa to the Indian Ocean and sinking over the Pacific, or vice versa. And that a lot of the time is driven by ENSO, or El Nino and La Nina. But this year, kind of having this more wave number 2 pattern, I think has been kind of one of the reasons why the season has been, on the underachiever based on what we would have expected from our seasonal forecasts. So this just kind of highlights the circulation pattern that you're looking for if you want a busy Atlantic season. So you basically want air going up from effectively the Western Pacific all the way back towards Africa, and they're sinking over the Pacific into the Caribbean. And the reason why you want the circulation pattern is because when you have the circulation pattern, it results in upper level easterly winds over the Atlantic. And really the big driver in general in the Atlantic is vertical wind shear. So when you have a pattern similar to this, you get reduced levels of vertical wind shear, normally leading towards a busier hurricane season. Another thing I want to talk a little bit about is that, we talked last year about African easterly waves, so these strong thunderstorm complexes coming off very far to the north. And so if we look at the low level wind pattern in 2024, so here reds are westerly winds, blues are easterly winds. You can draw an approximate area where these systems may have been coming off of Africa. That's fairly far to the north. But if we look at the same pattern in 2025, we see that it's much more, it's a little bit further to the south, so more at latitudes that we typically expect. And so this year, I would say, well, last year we had, especially during the middle to later part of August and early September, we had several weeks where the systems were coming off Africa too far to the north. And we talk about that in our lull paper. This past year, the waves didn't really seem to be coming off too far to the north. If anything, they just seemed a little bit weaker, likely due to the more sinking motion over Africa that I just showed. So just kind of highlighting how the stability issue, I think, was one of the reasons we had the lull in both seasons. But 2024 and 2025 were somewhat different when it came to the African easterly waves. In 2025, suspect they were closer to kind of their average latitude than they were in 2024, and they were shifted quite far north, especially that year from mid-August through early September. Now, it's tricky to verify a seasonal forecast in mid-October. Obviously, even if we'd done that last year, we would have said, probably less or not as close as we would have expected. But, if we look at the stuff now, right now we're tracking below most of our metrics, except for major hurricanes and days. If we do end up getting a major hurricane in the Western Caribbean in 10, 12 days, which potentially could happen. Obviously, that would make the seasonal forecast numbers look somewhat better. But probably overall, we're going to have somewhere between, a slight bust or a slight under forecast and maybe as much as a moderate bust if, say, this is the end of the season, although I doubt that that's the case quite yet. So it's hard to quite verify yet, but probably we're going to be on the high end compared with what was observed. So again, this metric that we focus a lot on, this accumulated cyclone energy metric, right now we're kind of at the low end of the ranges for our forecast, our July and August forecast. We still need a little bit more ACE to get the low end of our forecast ranges for April and June. So while we forecast kind of our best estimate, we obviously know there's uncertainty associated with the forecast. So we do provide ranges in the forecast to kind of basically give you the uncertainty, basically give you an estimate of how much uncertainty there is in this forecast. So the ranges in April, as you would expect, are larger than in June, which is larger than in July, which is larger than in August, because we're getting closer to the events that we're trying to predict. So again, we'll see how the final forecast verifies. It's not going to be a colossal forecast bust, but obviously if we end up with 4 hurricanes and say our April forecast, we predicted 9, that's a pretty significant over forecast. So we'll wait and see kind of how these numbers verify, but certainly the forecast is not as big of a bust as had I come on your show, say a month ago when we were talking about storms and the potential for that kind of bust. So I didn't know if you want to take a quick break now and do any questions, or if you wanted to just keep going and talking a little bit more about what might be coming the rest of the season. I think
we'll do a break, but we'll record that and drop it in. So if we've got any questions, I know we had a couple of questions from Casper Gregory.
Bill, do you see those questions? I did not see those questions from Casper.
Alex sent me the questions. I can mention those questions. So there were 2 questions. The first question was asking about the Atlantic Nino and Nina and how well can we forecast it, and then probably a little bit also about what that means for the Atlantic hurricane season. So we talk about El Nino and La Nina in the Pacific, and you do get something fairly similar in the Atlantic on occasion. So the Atlantic Nino basically is typically defined to be when you get warm waters right near the equator in the Atlantic. So this map is kind of a perfect map to show if, say, you have waters south of the Gulf of Guinea that are much warmer than normal, they'll talk about an Atlantic Nino. And there's been some work that shows that when you have an Atlantic Nino, that will enhance Atlantic storm activity, whereas an Atlantic Nina, when it's colder there, will tend to suppress it. Now, part of the challenge is that normally when the waters are warm, say near the Gulf of Guinea, they tend to be warm farther north in the tropical Atlantic. So it's hard to disentangle basically what is purely driven by that versus kind of the correlation with the rest of the basin. And so the question that was asked about was, how good are we at forecasting it? And so climate models in general do a better job, I would say, at forecasting sea surface temperature anomalies in the Pacific than they do in the Atlantic. It's not that they can't, and say that the European Center did a reasonably good job of forecasting the Atlantic Nina a couple of months in advance. How much that matters versus what's going on in the deep tropics itself, I think still remains to be seen. There's been some papers looking at the Atlantic Nina and Nina, but I haven't seen any that have tried to kind of separate its influence from the influence overall just when you have the warm waters near the Gulf of Guinea, how that typically associates also with warmer waters in kind of that main development region. So I think if you say have a year where you have an Atlantic Nina like we borderline had this year, I would say we didn't maybe get quite up to the Atlantic Nina threshold with a warm tropical Atlantic. How that relates is a little more unclear. That might tend to actually push your African easterly waves a little farther to the north. Typically that's favorable unless they go too far to the north like they did in 2024. So I think there's a bit of question on that. The other question was, and then we can also use this map to kind of highlight it, was about the Pacific Decadal Oscillation and how that may have triggered that trough along the East Coast. And so I kind of already talked about how I think Hurricane Erin played a substantial role. Typically when you have a negative phase in the Pacific Decadal Oscillation, like we have right now, a negative phase of the Pacific Decadal Oscillation is associated with warm waters from basically off the east coast of Japan all the way towards the west coast of North America. But it gets cold right along the west coast of North America. It's kind of your typical Pacific Decadal Oscillation, negative Pacific Decadal Oscillation pattern. If you look at this right now, we have basically warm across almost the entire North Pacific. So it's a little bit different from that. Now, normally if you have a negative Pacific Decadal Oscillation, it does very loosely correlate to maybe a little bit more low pressure along the east coast of the United States, but the correlations there are fairly weak. So I'd say maybe it played a secondary role, but I think the primary role in this case was due to Hurricane Erin. One thing I'll talk more about later is, looking at that really warm waters in the North Pacific. So here you're looking at sea surface temperature anomalies of 3-4 degrees Celsius. Like that's a big difference from average, and that can make differences in how the tropical circulation perhaps responds. So we're going to try to understand a little more of that as we try to kind of, improve our seasonal forecast in 2026 and beyond. So does Hal and Bill, do you guys have any other questions about what we've discussed so far? I certainly don't claim to have all the answers. I've got lots of questions, so.
Well, Phil, it's interesting. You were just talking about the Pacific Decadal Oscillation. I wanted to ask you, I've heard scientists suggest that perhaps the North Atlantic Oscillation, I've heard people say if you take the index in May and June, a positive NAO, you might tend to see the Bermuda High shift off farther to the east and allow more of these Atlantic hurricanes to stay out to sea. I mean, have you seen anything like that? Is that suggestion accurate, or is that pretty speculative?
Yeah, I think the correlations with the North Atlantic Oscillation are pretty weak. When you're talking about landfall versus non-landfall, there's two big factors. There's where the storm forms. Storms forming right off Africa, the odds of them hitting the U.S. are lower. Not to say they can't. You can get a Hurricane Irma, but in general, the storms that form right off Africa tend to gain latitude as they track across the Atlantic and recurve. Obviously, if you get a year like 2020, which was just a crazy year for landfalls pretty much everywhere in the basin, one of the reasons for that was a lot of the storm formed in the Western Atlantic, and if stuff forms at 60 west and farther west, it's probably going to hit somebody just because of where it formed. So I think that actually is probably more important in terms of driving landfalls. The other challenge is that, we get years like this year where you generally had a pretty persistent trough along the East Coast. Didn't move very much for several weeks. So that meant, the door was kind of closed for landfalls. A lot of other years, it's like you have a trough and then you have a ridge and it kind of moves back and forth, but it's just more normal. That's kind of what you expect is when you have weather patterns, they tend to change over time. And so, trying to kind of forecast like a monthly average position of the Bermuda High or troughs and ridge patterns doesn't give you a ton of information, I think, when it comes to landfall, because one, that pattern shifts day to day, week to week, but also a lot of it is critical is where are these storms forming relative to where these ridge and trough patterns may be. I think really what's been remarkable is the fact we've had nothing in the Gulf or Caribbean since June. That is just crazy. The last time that happened was 1991. And in 1991, the Atlantic was a whole lot colder. We had a marginal El Nino going on, just very harsh Atlantic conditions. So to have, two Category 5 hurricanes and overall, a near average season have nothing in the Caribbean and Gulf is pretty remarkable.
Thanks, Phil. Amazing insights there. Bill, I'm sure you have some questions. Let's pass the mic over to you. Bill, you might be muted.
Thank you. You look at that your graphic right there. And it's been that way all summer. Exceedingly warm conditions across the Caribbean and Gulf. I suspect the combination of the more stable air and the weakness of the waves coming off of Africa may be the key elements as to why nothing got cranking during the peak of the season in the western part of the basin.
Yeah, I would agree. It's one of those things where we're looking at this now and as of kind of starting to think about, okay, what might be coming down the pike in the next couple of weeks. The water temperatures, especially in the Caribbean, there's a lot of 30 degrees Celsius, 31 degrees Celsius water. So the system that we're going to talk about here in a couple minutes that might form in there, if something does go there, it has a potential to intensify very, very quickly because that area has basically been untouched. There's been no systems that really kind of mix the water. It's been a lot of stable air. So if you have stable air, you just have a lot more sun hitting the ocean, warming things up, and the winds have generally been fairly weak. So there's a reason everything there is warm. So obviously you need a lot more than warm waters to get storms because otherwise we would have had storms there the last few weeks. But if you do get a system in there with in a relatively conducive shear environment, which looks to be the case in the western half of the Caribbean for this particular system, it has a potential to go very, very quickly. And if you look at the model forecasts, a lot of the models are kind of deepening the system if it does form very quickly. Obviously, we're speculating about a storm that may or may not form in 10 or 12 days. So, there's still a lot of options on the table, but that's certainly, I think, probably the last potential threat for the United States, at least this year. Once you get into November, the odds of landfalls in the U.S. go way down. There's only been 4 hurricanes since in the historical record going back 170 years that hit the U.S. in November. The most recent of those was Hurricane Nicole. And so just a side note, I said, I'm going to go visit my mom in November. My mom was on the east coast of Florida thinking, okay, it's November. Florida doesn't really get hit by hurricanes in November. And my flight was canceled because of Hurricane Nicole. So shows how much I know. So climatology is great, but as Bill Gray, or as one of our professors used to tell Dr. Gray, there's no climatology in the vorticity equation. So sometimes storms may do things that are very non-climatological.
Yeah, there's every time you say it's never happened before, Mother Nature decides to show you, okay, let's make it happen.
Exactly. Yes. And you look at the last 2 seasons and you look at, some of the records we've set for just weird things. It's been, every season's weird, but these last 2 seasons have been very, very strange to have. Last year we had the earliest Category 5 on record. This year we had a monster Category 5 in August, and then these really pronounced lulls. And then right after the lull, all sorts of storm activity, just very, very strange. Obviously the rebound after the lull was not as dramatic in 2025, but we did have, a Category 4 and then yet another Category 5 hurricane. So 2 Category 5 hurricanes is, it's a healthy number. So hopefully we won't get a third one here in a couple of weeks.
No kidding. How about if I give a quick, here's what's going on in the tropics now. That'd be a great lead into what's going to happen the rest of the season.
Perfect.
Okay, if you'll unshare, I'll start sharing my screen. There we go. Beautiful view of CONUS today. The small amounts of active weather are non-tropical oriented. The high pressure that's been dominating our impending drought here in Texas, extending over the Gulf, keeps it pretty nasty as far as that goes. But for those that don't want anything in the tropics, it looks fantastic. The overall, the basin, the Lorenzo, I thought maybe they would bury it with this morning, but it's still on the advisory forecast to bury it tonight. Frontal systems all the way down into Cuba right now, and very active across the North Atlantic. This is the one wave that came off Africa either yesterday or the day before that we think the models are picking up on for week 2 type development once it gets over in the Caribbean. The 7-day outlook, nothing is carried in the current outlook from NAC. There is I'm not going to talk about Lorenzo because there's nothing much to say other than it's fading away. There is a system expected to have potential to develop. It's carrying it with a 40%, the next 2 days, 60%, typical right off the southern coast of Mexico. And that may become a player with the way the West Coast troughs have been of injecting more moisture into the Southwest, but it's too early to be more than speculative about that. The CPC weeks 2 and 3 tropical outlook, they capture the area that Phil's going to tell us all about here in the Caribbean in the week 2, and then go pretty much silent after that, with the action being over here in the Western Pacific and Indian Ocean, and we're even starting to get some hints that things will get going in the Southern Hemisphere kind of early on their stage. In there, let's see, I think I had one more thing. Oh yeah, the ensembles. I'll let Phil continue that discussion there, but just for those that hunger for active tropics, that's what we're looking forward to in the Indian Ocean, and one typhoon in the Western Pacific. So with that, I'll stop sharing and pass it back to Phil. What did I say that was wrong there, Phil?
No, everything sounded good. It's thanks for highlighting all this stuff. It's been interesting. One thing I think it's been interesting is that we've generally had kind of a Central American Caribbean gyre. And normally with a La Nina that we currently have, you would expect the gyre storms to form on the Atlantic side, but they've all been the Eastern Pacific side. Even now with this thing it's like they just keep forming on the south side, it's just interesting. I don't know exactly why that's been the case, but had I been on your show 2 weeks ago, I was really hyping the gyre, so we should get something. And the models for a little bit were keying in on something about now forming in the Atlantic side, but everything just seems to be wanting to spin up on the Eastern North Pacific side of that gyre. The gyre's probably, this looks like maybe the last Eastern North Pacific system, maybe one trailing this one. Both this one and the next one, obviously, they're very close to land, so it maybe end up, what was it, Raymond, that, basically was there, but didn't last long. It was too close to land to really get intensified. But I do want to point out that, being in Colorado, we did have some significant moisture impacts from Priscilla, especially. Not where I live, but down in the southwest part of the state, they actually had some pretty significant flooding.
Yeah.
But it's a double-edged sword. Well, it's good and bad. Obviously, it's bad. The flash flooding's no good, but we were in a pretty significant drought. So I suspect, haven't looked at the drought. Well, I guess the drought monitor comes out in a couple of days, but I suspect we'll be knocked down at least one, if not 2 categories in the southwest part of Colorado, given how much rain fell. One thing that Priscilla did provide, which is extremely unusual in Colorado, we did get quite a bit of moisture, and we actually had a rainbow at sunrise, which is not a common occurrence in Colorado. We get plenty of sunset rainbows, but not a lot of sunrise rainbows. So thanks to Priscilla, we had dew points in the mid-50s, which I know by Texas standards is a nice dry day, but by Colorado standards, that's a juicy atmosphere. So it was interesting to see a morning rainbow.
Yeah, the Caribbean side, the Atlantic side of the gyre actually did produce some fairly tragic flooding in the area of Poza Rica, which is north of Veracruz in eastern Mexico, and it was kind of the Atlantic side of the event that led to Raymond. So it didn't grow a cyclone there. It brought the moisture with it, and the terrain enhancements you get there. They had some serious flooding.
Yeah, and the gyre is a tricky one because the gyre sometimes will spin up nasty storms. Sometimes it spins up sprawly storms. Sometimes it just develops a bunch of rain. And so you can get cases where you get storms on both sides too. Like last year we had Helene, which is a large large storm in size on the Atlantic side, and we had John, which was a tiny storm on the East Pac side. So the gyre is a little tricky. You never quite know what it's going to spin up, but it really didn't. I would have thought a couple weeks ago we would have gotten at least one hurricane out of that, but it doesn't look like obviously that's going to happen. But we'll be watching the other area. So I'll just dive in and finish off what I've got here. So just to highlight, am I sharing my screen?
Not yet.
I'm not yet. Okay, hang on. Sorry. You'd think I would know how to do this since I already gave like 2 presentations this morning. All right. Share back here. Okay. Current slide. All right. Participants can now see your application. That's what I want to see. Yeah. All right, so if we look here, we're focusing on 2 different regions. So that blue rectangle, that denotes the region that NOAA uses to monitor El Nino and La Nina. So water temperatures in that rectangle are cooler than normal. And NOAA actually just officially declared La Nina. And if we should look at the Atlantic, we see the Atlantic in general is pretty warm, especially in the Caribbean and Gulf. We already talked a little bit about why that's the case, but there's plenty of fuel there if something does try to develop here late in the hurricane season. NOAA officially did declare La Nina. This is the Nino 3.4 region, which is the box or the rectangle that NOAA uses to monitor El Nino and La Nina. So water temperatures in that box are 0.5 degrees Celsius colder than normal or colder than that, NOAA will declare a La Nina, provided they persist. So we just reached that threshold long enough. Last week, NOAA declared La Nina, and La Nina tends to be associated with busier Atlantic hurricane seasons. The reason why is because of how it alters the tropical circulation. So I figured I'd show this nice graphic from climate.gov highlighting how El Nino and La Nina alter the tropical circulation. So in an El Nino event, you tend to have warmer water in the eastern and central tropical Pacific. In response, the strong thunderstorms shift from more near Indonesia closer to the international dateline. When you think about the circulation in thunderstorms, you have what Bill Gray used to call an in, up, and out circulation. So at low levels, the winds converge into those thunderstorms, they go up in the thunderstorms, and spread out at high levels. So if we look at the circulation in the Atlantic, you'll first of all see a down arrow, which means sinking motion, which suppresses storms. But you also will see increased winds you see winds out of the west, high up in the atmosphere, winds out of the east, lower down in the atmosphere, and that is basically the same as the prevailing winds in those directions. So normally the winds in the Atlantic blow out of the east at low levels, out of the west at upper levels. So that increases your vertical wind shear. Whereas in the La Nina, you basically have the opposite circulation, reducing your vertical wind shear. And this is a plot that Dr. Gray, I think, designed like 30 years ago, but I still show it for old time's sake. Similarly, just highlighting how El Nino, you tend to get fewer TCs and more levels of vertical wind shear. In this case, TC stands for tropical cyclone. This is the official forecast from NOAA. So again, we have La Nina. It's forecast to be fairly weak. And you can see even by January, February, March, so that 5th bar chart there, 5th column of that bar chart, you can see they're already going back to neutral conditions. Obviously, the big question I figured just for 2026 is, do we go over to El Nino? Obviously, I'm not going to forecast El Nino this far, but the odds would say are higher than say they were last year when we had just come out of a strong El Nino for 2024. Usually if you come out of a strong El Nino, it's going to be at least 2 years before another El Nino develops, just to take time to recharge what we call the Western Pacific warm pool. There's been quite a bit of recharge that's happened in the last few months, so we'll see what happens for the 2026 Atlantic hurricane season. But obviously that's something we're monitoring very closely, but we still have certainly several months to go before our outlook for the 2026 season. As I mentioned before, the Caribbean is quite warm. There's plenty of water there. It's 30 degrees Celsius, some approaching 31. That's basically rocket fuel for storms. But as we've seen this year, we've had nothing there despite very warm waters. You need a lot more than warm waters to get a hurricane to go. As Bill showed in the satellite loop, there is a system in the eastern Atlantic, tropical wave, tropical strong thunderstorm complex, what we call an African easterly wave, that some of the models are keying in on and potentially intensifying once it gets into the Caribbean. The main development region right now is running quite a bit above normal. If you look at the correlation historically between accumulated cyclone energy, so again, the integrated intensity and duration metric, correlated with sea surface temperatures, correlation's pretty high in the main development region, but you see the darkest colors are in the Caribbean, because that's where you tend to get your strong storms this time of year. Heat content's very high. Of course, had we not had 2024 and 2023, we'd be talking about probably record-breaking heat content, but because of those 2 years, it's lower than those 2 years, but certainly still well above the long-term average. I just pulled this plot a few minutes ago. This is from the National Hurricane Center, highlighting where storms tend to form towards in the last, say, 11 days of October. You can see kind of that big cluster in the Caribbean, and that's especially where your storms that become strong tend to develop, is in that region, because it tends to be where your shear is low. If you look east of the islands, not much, very few dots, and that's, again, because typically the shear in the eastern Atlantic gets high faster, which is why your storms tend to shift farther west late in the hurricane season. As Bill showed, not much in the tropical weather outlook for Lorenzo. There is a potential again, though, for a storm formation as we move further into later in October. So this is kind of the wave that would, if this system does form, is likely to be kind of at least part of the genesis for it, is this tropical wave. It's a pretty robust wave. It's been had pretty strong thunderstorms associated with it since it emerged off the coast of Africa a couple of days ago. You can see in the models, I think Bill already showed this a little bit. These are kind of highlighting the ensemble forecasts. So this is basically 51 different forecast models basically being run to kind of give an idea of what may happen. And so, it's not like 51 members have a Cat 5 hurricane, but it's highlighting how there is a potential for storm formation once the system gets into the Western Caribbean. Now, normally storms, if they don't form by the time they reach the Windward Islands or Leeward Islands, they don't tend to form till they get to the central part of the Caribbean. The reason for that is because effectively of the South American continent. So the South American continent, goes up to about 10 degrees north in that region. And because it does, what that happens is the continent, the land heats up faster than does the ocean. So you tend to get a thermal low pressure there, and the circulation around that low pressure on the north side of that low is winds out of the east. So you tend to get kind of enhanced trade winds, which tend to move the system along faster and also increase levels of vertical wind shear. You also do tend to get some dry air mixing down from the continent, which is often why when you look at storms forming, they tend to form somewhere between 70 and 75 degrees west, or even farther west in the basin. If a storm does form, obviously there's really no guarantee where it's going to go. One of the things that we see, though, is that if the storms forming a little bit farther north tend to have a better chance at getting strong just because there's more ocean. So for example, if you look at the Caribbean and you look, say, at the northern coast of Honduras, if the storm goes north of there, you've got several more degrees of longitude to work with, which could be an extra day over very warm waters. Whereas if a storm makes landfall on a place, say, like Nicaragua, it has a lot less warm water to work with. So that is one of the questions, if a system does form, is exactly how it tracks for example, to see how strong it could potentially get and obviously how long it would last. We can see how, for example, we looked last year at Tropical Storm Sarah. So Sarah formed just north of the north coast of Honduras, but it was very close to land, so it never got very strong. But if you looked at all the environmental conditions for that storm, the only reason it didn't get strong was because it was close to land. Had it been 100 miles further north, probably a major hurricane because it was in very warm waters, very low shear, and plenty of moisture. So again, we're speculating about a system that may form in 10 to 12 days. So this is not something, that people need to be worried about right now, but this is definitely, I think, one of the higher potentials that we've seen this year for something forming and potentially having, some significant impact. So this is probably our last shot in terms of a significant impact potentially for the U.S., but even there, probably more likely to be more of a Caribbean storm. And even if it does track north, maybe going farther east over the Bahamas and then maybe heading out to sea. So a lot to kind of monitor, but certainly nothing that we want to be too worried about at this point, but just something to pay attention to. If you like the AI models, the Google DeepMind model's been pretty solid. Genesis in week 2 has been not its strong suit per se compared with its track and intensity forecast, but certainly been okay. So just kind of highlighting similarly, a lot of orange and purples and stuff late in the period. So again, something that needs to be watched. Beyond that, though, the Matt and Julian oscillation, which hasn't really done a whole lot this year, is actually developing and intensifying. And so the Madden-Julian Oscillation is tropical convection or strong thunderstorm activity that propagates around the globe about every 30 to 70 days. Now, sometimes it's strong, sometimes it's weak. When it's strong, it can really modulate levels of vertical wind shear. And so typically the Atlantic is favored when it's in phases 1, 2, and 3. So where you see the red dots, the purple dots, and the orange dots. So through about days 10 to maybe 15, and then it goes into less favorable Atlantic phases. And we can see that signal popping out in the forecast of vertical wind shear from the European center. So here, blues are low shear, reds are higher shear than normal. And so if we look at, say, the last 5 days and the current 5 days, the shear is fairly low. And then you see that the blues persist in the Western Atlantic, but if you go further east, the shears get a lot higher. And so that is obviously, we're not expecting to see much more coming off of Africa, but still, maybe stuff farther west in the basin. So not saying the season is over, but probably at least following this system, it may be quiet, maybe picking back up potentially late, in November, but obviously then you're starting to get really late climatologically or on average. So not saying the season is done after this potential system, but at least the Eastern Atlantic should be quiet. And as Bill showed earlier, the Climate Prediction Center didn't have any tropical cyclone shapes for week 3. There's just no areas that are likely to be super strongly favored at that time. And once you get into November, the shear along the U.S. coast tends to be very, very high, which really reduces your odds of getting landfalls once you get into November for the United States. Certainly Caribbean can still have significant impacts during November. Lastly, 2 things I want to talk about. There's obviously the last 2 seasons have been unusual. And if you look at the Atlantic, both these years, the Atlantic was very warm. And both years had 2024 had cool neutral, 2025 are a little more towards La Nina. But both of those years obviously had these really pronounced lulls and kind of had weird stability issues that we wouldn't have expected given how relatively low this year has been. And so one of the things we're going to be looking at is, do sea surface temperatures in the North Pacific, so especially north of 30, are these playing a role? What's going on there? And so, it's hard from a observational perspective because we only have so many years, and so it's hard to make a judgment off of 2 years. But what we can run is you can run a climate model simulation where basically you run it with the current sea surface temperatures, but then basically take the North Pacific north of 30 and say make it average as opposed to 4 degrees warm and see how the circulation changes. So we're going to be running some climate model simulations with some partners from other universities on that. And then the other question that we're really trying to get at is, how do we improve these years where the shear-ACE relationship does not hold well? And so really when we do a seasonal forecast, we're not necessarily really forecasting Atlantic hurricanes. We're really forecasting the shear. And the shear, normally when the shear is low, you get more storms, and when the shear is high, you get fewer. And those years where that shear-ACE relationship doesn't hold very well are the years historically we tend to bust. We tend to bust for 2 reasons. One, we anticipate, sea surface temperature and large-scale conditions that are different from what we get. In other years, we anticipate the conditions quite well, like 2024. Last year, we said, hey, very low shear. We got the lowest shear on record, and we ended up with a busy season, but not as busy as we were anticipating. Alternatively, there's some other years, if you look at these years where the average August to October shear was 7 to 8 meters per second, there's a huge spread in those years, right? You look at the shear in 2017 versus 2013, on average, not much different, but obviously very, very different from an impacts perspective. So trying to kind of get at maybe some other stability and precipitation metrics to try to kind of better understand, what's going on here. Also working with some colleagues both in our university, looking at potentially using these kind of machine learning climate models to basically re-simulate hurricane seasons of the past to try to better get an idea of, if you force a season with sea surface temperatures, just run sea surface temperatures and then see how the atmosphere responds. How different is the atmospheric response to those sea surface temperatures if you just run it for a year and see what happens? So I think that can kind of help us maybe understand a little bit more of the internal variability of the climate system, because obviously in the real world, we only have one answer. This is what happened. But obviously the question is, if you were to run this year again, how different would it be starting June 1st? How would things play out? Because obviously you look even at like Umberto and Imelda, if Umberto wasn't there, Imelda was probably a landfall into the Carolinas and a big flood event. But Umberto was there and it pulled it out to sea. So all these kinds of storm interactions and all this other stuff, kind of basically trying to better understand which years did we really bust and which years were more just, effectively overachieving or underachieving hurricane season. So trying to kind of get a better idea of what is kind of the expected internal variability of the climate system. And so that's my contact info, and happy to talk a little more hurricanes. I know we're getting a little short on time, but I'm happy to do any more questions if there are any.
I do have one. I'm intrigued with the tendency for almost all of the waves this year being weak. How well can we forecast in advance whether we're going to have weak easterly waves coming across from Africa versus moderate or strong?
Yeah, so we look a lot at what we call the tropical easterly jet, which is effectively, so you have the African easterly jet, which maximizes at about 600 millibars, but you also have the tropical easterly jet, which is at about 200 millibars. And so that, when that's strong out of the east, that tends to be more robust African easterly waves. Now, this year, the easterly jet has been pretty strong, which should be more robust waves. I have a colleague that'll be able to run it once you get through October, kind of diagnostics on the season. My guess is, overall, if you looked at all the waves, it was probably about average, but it's hard. I'd have to see kind of exactly. Certainly not as robust as they were last year. I would say during the lull, they were pretty anemic. The ones coming off recently have been more robust. We've seen, of course, the storms haven't done all that much, but certainly the way that formed Jerry was very, very active, very convectively active, as was the one that formed Lorenzo and the one that, is out there right now. Those waves actually do look fairly healthy, but overall, what the wave amplitude is right on the west coast of Africa, I would guess about average, but I'll be able to quantify that once my colleagues run some numbers here in a couple of weeks.
Interesting. Hal.
Yeah, Phil, so many professionals, especially in the, I'd say, construction, insurance industry, to saying, well, this year nothing happened. There were no impacts. How close did we come with these factors to where it could have been a very different story? I mean, 3 major hurricanes west of 60, incredibly low shear in August and September, warm SSTs. I mean, could this very well have been a different story if you kicked that trough off the East Coast?
Yeah, I mean, it's hard to say for sure. I mean, obviously, Aaron was not that far offshore. Obviously, that goes a few hundred miles farther west, and people are talking a different story. I mean, obviously, if Umberto wasn't there, then maybe Imelda goes up into the Carolinas and causes flooding. I mean, you can always do these kind of hypothetical situations. But certainly the fact that the Caribbean and Gulf have been so dead, certainly does reduce the odds, especially for the Gulf Coast. If nothing's in the Gulf, it really reduces. So, the storms that did form tended to form fairly far to the east in the Atlantic, which again tends to reduce their odds of hitting the U.S. But certainly with a couple of storms, I would say certainly with Aaron and with Imelda, we got fairly lucky with how things played out. Those could have been different in terms of they weren't that far offshore. I mean, obviously Aaron, given how large it was, I was on Mount Washington on August 21st, and nowhere near where Hurricane Aaron was, but you could see the cirrus looking to the south from the top of Mount Washington in New Hampshire. So that storm was absolutely enormous. I mean, obviously did bring not cataclysmic impacts. It did bring a fair amount of coastal beach erosion and some houses lost, even though it was still several hundred miles offshore. So, anytime there's storms tracking, but again, these storms not only have missed the U.S., they've also managed to generally Imelda hit Bermuda, but everything else is kind of even missed Bermuda, missed the Bahamas, missed the Caribbean. Like, it's just been a remarkably kind of benign hurricane season. And so the last time the U.S. did not have a landfalling hurricane would be back in 2015. So for the U.S., it was, it's been a while. It does happen. I think it's about 1 in 6, 1 in 7 that you don't get a landfalling hurricane, but it's not unprecedented, but certainly it's been a while.
Phil, thank you so much for joining us today on NTWC Plus. Always great to hear your insights on this. Bill, do you want to close with one final question? And then maybe we can go to Alex to mention our sponsors once again.
Yeah, I think just a comment. I don't know about Hal and Phil, but I haven't had anyone complain to me about no impacts. And our forecast of gloom and doom, even though it really wasn't a gloom and doom forecast, didn't come to fruition. So, Phil, it's always great to catch up with you, and I look forward to comparing notes in April when you're down on South Padre with us.
Thanks so much.
Thank you again, Phil, and of course, Bill and Hal for being with us today. And we'd like to really mention our sponsors, USAA. They've been sponsoring us for a long time. They help us keep this program going, and the National Tropical Weather Conference as well. South Padre Island Convention and Tourist Bureau, the Weather Company, Weather Boy, and Live View. Thank you very much for joining us today, and join us next week as well.